Hi everybody. What I'd like to do in this brief video, hopefully brief, is to demonstrate the processing of astrophoto images using ImagesPlus. And what I have in front of us now are four Nikon RAW files that were taken. And these FIT files are what are called bias images, and we'll see what those are shortly. Now, a bias image is simply a very short, sometimes 0-second exposure of a frame of a camera. What it records is the CCD's read noise. Read noise is probably is one of the largest detriments to photography of any type, astrophotography or whatever. So you're seeing a screen that is a snapshot taken with the camera, with the lens telescope covered. So it's essentially a very short dark frame. We'll get into a dark frame later. But what this is showing you is any variability or variation in the read noise of the CCD chip. And this image, of course, is very clean looking as opposed to some that can show a lot of variation. In fact, I'll bring up one here in a second. I'm going to pause here. Okay, camera chips for the newer cameras these days are pretty good. I'm going to show you an older camera. This is the SBIG STF-8300M monochrome CCD camera, and as you can see along the edge, and by the way, a bias frame repeats. You can use this frame over and over again. Notice the light area along the edge, some of the darker areas. So now let me show you the latest that we have. And here you see the bias frame for the Nikon D5300. I might have had this up a few moments ago. Again, very clean image. So we're going to go into the image processing aspect of astrophotography. To do that, I'm going to bring up ImagesPlus. Actually, ImagesPlus is divided into a camera control side of it and image processing side of it. Mike Unsold separated those two products into different installations several years ago. Okay, enough of that. Okay, so what we do is we begin by selecting our type of processing that we're going to do here. We're going to choose DSLR as opposed to a mono CCD, which I would use, which would be the method used for say an STF-8300M mono CCD. So I choose this, I choose the type of camera, and at the moment there's a question as to whether this list will process for the newer D5300. I'm waiting on word back from ImagesPlus on that. Now, the first thing you do is go in and select your light frames. I'm doing a range select here, okay? In other words, click the top one, hold the Shift key, click the bottom one, open those. Now, I have no dark frames. I'm not using flat frames. I will, but not at the moment I don't. Okay, I'm going to select the bias frames. And, okay. It defaulted to using the previous calibration frames I had recorded. So here I'm doing a range select on the bias frames, and we're going to open those. And now we're going to select our method of processing. Okay, so here we select light frame processing parameters. And first of all, there's a choice of the various intermediate and final output formats. I'm going to choose 16-bit TIFF. There's the option of lossless fits. You would use fits for other purposes, one of which would be to convert an image for plate solving, but more on that later. I digress. Okay, let's go down here. we're going to choose the default of minimum, maximum, excluded, average when the 4 images are combined. Okay, and here what I typically do is I change the output 160.330 underscore M66 M65 underscore combined. Although I can always rename the output later, I like to set that up right off the bat. Okay, so I click Save. I click Align and Combine. Now, we could check these other options. What this would do would be to normalize the exposure across all 4 images, but they're very similar. Grading would pick the best 2 or 3 out of the 4. This is something you might do if you are using 9, 10, 11 exposures and you want the best 90% of them. But with just 4 exposures, I'll go with the options to simply line up or stack the images and then combine them. So let's watch how quickly that happens. And this is starting at 8:28:36 a.m. And then I'm going to pause and we'll come back to this. Okay, it's converting the individual image files to RGB color. In other words, it's debayering the individual light frame images. And now it's analyzing the first image, which it is considering the reference image, in preparation to align the images and stack them. It's begun to align the images. That could take a few moments. Now take into account the fact that these are huge files, 24 megabits each, 6,000 by 4,000 array. This is one of the reasons you get a faster processor, and a solid state drive helps. Okay, now it's combining the frames. I think I'll just let this run since it's almost done. There. So we don't need the clock any longer. And so what I can do now is display the finished result here. We no longer need this. And then I'm going to do a simple quick stretch there. And as you can see, this is a pretty good looking image, if I do say so myself. And there's a considerable amount of more processing that could be done on this. But I think we will get into that somewhat later. For the moment, I'm going to save this. One of the neat features of ImagesPlus is it will save a text file showing you any and all processing history. There. Okay, we'll close this out. And now I'll show you what that looks like. The finished product looks like. Okay, here's the text file. Okay, here's that stretched version of the Galaxy pair. And there are a number of things we can do with that here. We can boost it up a little. This is not what I would normally do, but just to show you. What I'm playing with now is a tool called ImagesPlus. It's a form of Photoshop. Okay. So, let me do one quick pass of sharpening in here. I could crop this portion of it. Zoom in, and there's M66. Okay, more on processing later. And I'm going to close that without saving it. Okay, we'll pick this up later. Thank you.